Erica, are you here?
I'm here, yes.
Okay, let's start by looking at your work. This is what Erica has as her answer. 12x cubed kx plus 6x to the power 4, the derivative of k of x plus 12x squared times k of x plus 4x cubed times the derivative of k of x all over 3x plus 2 all squared. Erica?
Yes.
Erica, are you sure about this piece of work? Are you proud of
I
it?
was, but now you make me doubt it.
There is, you need to believe in yourself. All of us, let me give you this friendly advice, Erica.
Yes.
Everybody out there, no one will actually compliment you. No one will, even on a single day, it is hard for them to say, Erica, that is a job well done. But it is up to you as an individual to say, you see, on this one, I've done my best. No matter what Glenn can say or whoever can say, I've done my best. Okay?
Okay.
Yes, yes. That is the spirit that will drive you. Because
So
if you
that's the
can listen to
answer
all
I
these,
got.
sorry, that's the answer
That's
you
the
got.
answer
If you
I
can,
got.
okay, thank you. All these other people will try to bring your spirit down, and you must not allow them. Okay, this is your answer, Erica. Ne? Please
Yes.
stick by it. Now, where should I go? Now coming, where? This is Erica's work. Now we are stepping off Erica. Erica. Now we are coming to our, oh no. Let me go. Lebo, are you here, my sister?
I'm here, sir.
How are you?
Not good.
What's wrong now?
Ngiphathwe nge-flu, sir.
Flu?
Yes, sir.
Yeah, just go to the chemist and get something. Lebo,
Okay,
can you
sir.
see what you sent through?
Yes, sir.
Are you sure what you are looking for? Lebo ne flu yako. Are you sure this is what? Are you sure about this?
I'm 100%.
Thank you. Now I'm going to Masha King.
Yes, sir.
Masha King, how are you?
Good, thanks. How are you?
Good. This is your answer, ne? The final step is your answer. Ne?
Yes.
I've already spoken to Erica and Lebo. Is there similarity?
It looks similar to Erica's.
It looks similar to Erica's.
Yes.
Not that one of Lebo.
Well, with Lebo, she ended a step before my final step.
Okay.
Yes.
Thank you. Where do we go now? Lerato. Lerato?
Yes, sir.
Oh, there are two answers here.
Yes,
Lerato,
that one.
you have got here. I'm reading before this, before or, the last step before or. It is 12x, the second derivative of k. Lerato, we don't, yo, this is not how we write, my brother, man. This x must be in bracket. Lerato,
Yes, sir.
the x must be inside the brackets. Okay.
Okay, sir. The X will be
Okay.
inside the
Okay.
bracket.
Thank you. Yes, inside the brackets. Are you saying here there is also a O here?
Take the last one, the second
Which one? This one?
Yeah.
Or is this the one that we need to consider?
Yes, that one.
18x squared k of x, not kx, né?
Yes, K of X, the bracket. I'll put it. Yeah.
Okay. K of x. When we say k of x, we are saying k. Then once we say k of x, then we know that that x is inside the bracket.
Okay, sir. I'll put it.
Minus 6x cubed, the derivative of k of x, plus 12x cubed, the derivative of k of x, plus 24x k of x in the
Yes.
numerator.
Yeah.
Is there a similarity between what we are looking at here and what we have already seen since we started?
Like, I'm not completely sure, but it's like labels one.
Levels 1.
Yes.
I'm also not sure, but let's. Makwena,
Yes, sir.
how are you?
Good, thanks. How are you?
Good. This is what you shared with us, my sister. Ne?
Yes.
12x cubed, k of x, plus
Yes.
6x to the power 4 times the derivative of k of x, plus 12x squared, k of x, plus 4x cubed times the derivative of k of x, all
Yes.
over. Hey, something is not making sense here in the denominator.
I forgot to write 9x squared. There is 9x squared plus 12x plus 4 in the denominator. Yes, sir. Yes, sir.
Do you want to kill me?
No, like in the denominator, I made a mistake. It is 9x squared plus 12x plus 4.
I almost collapsed.
Sorry, sir.
Yeah.
I made a mistake.
Okay, thank you. Now let's go to Ndumiso. I'll have to expand this one. Yes, Ndumiso,
Yes, sir.
you have got 6x to the power 4 times the derivative of k of x,
Yes, sir.
plus 12x cubed times k of x,
That's correct, sir.
plus 4x cubed times the derivative of k of x,
Affirm, sir.
plus 12x squared times k of x,
Affirm.
all over 3x plus 2, everything raised to the power 2.
Affirm, sir. Yeah, yesterday my foiling let me down a little bit during class.
Sorry?
So I'm saying yesterday my foiling let me down while we were doing it during the live session. So when I took a little bit of a break and went back, things started to look better.
Oh, pieces started to flow to fall into their own places.
Yes, sir.
Okay, thank you. Is there similarity between your answer and
I believe it's similar with Erica's, and I believe it's let me just check. Mashaking, yeah. Erica and Mashaking.
again?
Yes, sir.
Okay, thank you. Now, Tabo. 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 Tabo here? No. Okay, we're stepping off this one. Tando. Tando.
Hello. Hello. Hello, sir.
How are you?
I'm fine. Thanks. How are you?
Are you sure you are fine?
Yes.
Yeah, I'll only be fine if your answer is what we are looking for. You say, here, collecting like terms. Then we've got 12x cubed, k of x plus 12x squared, k of x plus 6x to the power 4 times the derivative of k of x plus 4x cubed times the derivative of k of x, all over the denominator. Tando, are you sure that this is the gun that you will use to kill many enemies if you were sent to a war? This answer of yours.
Yeah, I think
You think
I did my yeah.
You did your best. You applied all the rules.
Yeah.
Okay, thank you. Theo,
Good afternoon.
how are you?
I am quite well. Thanks for asking. How are you?
Good. Now, let's talk.
Yes, sir.
Saying here, this savannah that we drink will make us to can be able to solve any problem. Because remember, some years back, there was another advert of savannah that the man with the dark goggles used to say, there is no cant in savannah, meaning, according to him, you can solve anything.
Pretty
you remember
much.
my boss liked that advert?
Yeah, I remember it actually.
Yeah, my boss used at work when we were given work, he said, there is no cant. Remember, always reminded me of that advert. Says, in savannah, there is no cant. So now in your case, we have got 12x cubed times k of x plus 12x squared times k of x plus 6x to the power 4 multiplied by the derivative of k of x plus 4x cubed times the derivative of k of x. Magwena,
Yes, sir.
do you see the denominator?
Yes.
Are you saying this is how you should have written it?
Yes.
And then what happened?
I just forgot to write it's 9 squared, 9x squared plus 12x, and I wrote 2x by mistake, and I forgot the squared on the 9x.
What were you smoking?
Yeah, I was.
What were you drinking, if I may ask?
I was drinking tea.
You're drinking tea. Okay. No, I got surprised. I didn't understand. It took me some time. I was trying to figure out what is this person trying to say here.
Ish.
Then I just said
Okay.
to myself, huh? Only you, the writer, you are the one who
Would
can only be able to provide me with an explanation.
say,
Yes. Now, let me thank all of you for having taken your time to go through this. Now, everybody, with a piece of paper, the one that you send through, remember that here is a matter of applying Lerato way. Lerato,
Yes.
my brother, we are using the quotient rule as well as the product rule. Okay. Are you with me?
At the same time.
Now,
It's a combination.
sorry, level.
It's a combination.
Please tell Lerato.
Lerato is a combination of rules. You
No,
see
like-
that
My-
example 2.2.10, they say combining the quotient rule and the product rule.
Like, does it have order? Whether we started this one first before this one?
Which one? What are you saying when you are saying this one, that one?
One.
On my case, I did the product rule first, and here they say apply quotient rule first. So
We don't know.
Lerato, like you can take 2x squared k of x as one function for you to derive to apply the quotient rule, right? Like the way they wrote here. And then after that, you will derive your 2x squared k of x using the product rule.
also, when you're using the quotient rule, 2x cubed kx, you treat it as one entity.
You first treat it as one to apply a quotient rule, right? And then on your next step, you derive this whole thing, the 2x squared k of x. Remember, those are you use the product rule now to derive that.
Okay.
I don't know.
Yeah.
Lebula, can I ask why you still on it?
Yeah, Lerato, you understand?
Let's see the answer,
Like-
then I'll tell you
Wait,
if I
can
or
I
not.
add
I
to
don't
this?
understand.
Can I
I
add
don't
to this?
understand.
Can I add to this?
Yes.
Sure.
Okay, so how I always look at this kind of thing, Lerato, is first and foremost, what's the big picture? What are we doing? What's the big picture? And the big picture is we've got a situation where to get the derivative of this function, we have to use a quotient rule before that. That is before everything. And then you're like, okay, it's a quotient rule question. You start there. That's the big picture, right? But the quotient rule says at some point in time, we'll have to find the derivative of the numerator and the denominator. Getting the derivative of the denominator is going to be straightforward because we can see what it is. But now, remember, big picture, quotient rule, and then you start deriving. When you get to the numerator, now you need to get the derivative of the numerator. Now you need to be like, okay, what's the subtopic here? To get the derivative of the numerator, you need to use the product rule. So you basically need to use the product that you basically need to use the product rule in order to get the derivative of the question, which is in itself a quotient rule question. So always think first, what's the big picture? And then what roadmap am I going to use to get to the big picture? In this case, big picture, quotient rule. And then roadmap, in order to get to the end destination via quotient rule, I will have to use product rule to get the derivative of the numerator. Look at it that way. Big picture, roadmap. Because you'll come across these things a lot where the big picture is I'm trying to do this, but in order to get there, I'll have to take a detour here and there, then get back onto that freeway again to get to my destination. think about it that way, and you'll always figure these things out. And by also understanding what your big picture is, it's also going to guide what you do first and what you do secondly. I hope that helps.
It's like,
It helps.
you know, Sir, what's his name? Sematip. Yeah, I think that's the name. He always say, he always says, what's this thing? Maths, building blocks. I give you the tools. What. So here, if we separate 2x cubed and k of x and make them two different functions, like instead of one big question, you make it a small question like 2x cubed divided by 3x plus 2, and then you have it, you do it, and then you do kx divided by 3x plus 2. Will you still get the same answer?
No, it
don't-
won't work. And you know why it won't work, Lerato?
The denominator, the numerator. Okay.
It's not 2x cubed and kx. There is no sign in between. If there were sign in between, that's where we are going to say 2x cubed divided by 3 plus 2 plus, if it was plus in between. Now it's a multiply between 2x cubed and kx. So if it's a multiply is a product. So you have to use the product rule.
Leo, I'm glad you said that. Sir, can I please ask for a favor? Do you mind
Yes.
putting my solution back up on the screen?
Your solution.
Yes, please, sir. I want to use it to further explain this, Lerato, to explain what Lebu literally just said.
Okay.
And again, we're going to have one of our, yes, please take it to the top. I want to see the top of the solution, please, sir. So, right, top, please, sir. Thank you. So, Lerato, look at this. Look at what I did here. So, again, remember I said big picture and then roadmap for the big picture. And I said to you, big picture is quotient rule. And in terms of our quotient rule, our F is our numerator and our G is our denominator, right? And so if F is a numerator, you don't separate your F because that's your F. And then your G is a denominator. You don't get to separate things the way you want. If F is a numerator, you keep it as it is and you treat it as one entity. And then you derive that one entity, even though that one entity technically is made up of two things that are multiplied with each other. You see, because now the thing that you're doing now is if you're going to take a 2x cubed divided by the denominator, you're separating your F. Whereas your F in its entirety is actually the denominator, and the denominator is 2x cubed multiplied by k to the x. And if you look to the right of my solution, you'll see I even said there, F is 2x cubed times kx, and then F prime is now the derivative of the entire entity. And in order to get the derivative of the entity, you use the product rule. And then you go to the denominator, and that entity is the 3x plus 2. And then to get the derivative of that, which is my G prime, you treat it as a whole, you derive that thing as it is. And remember when you spoke about the other day where I said, you need to understand that you can't disturb the sanctity of your mathematics. And in this case, the sanctity dictates that your numerator has to be kept together as F. And so F is the whole thing at the top. Yes, deriving it means you're going to have to break it down and derive it separately via product rule. But in the essence of it, F as a whole is the whole thing at the top. And then F prime is that long thing that's going to be the derivative of the thing at the top. You don't break it down because quotient rule states that you're going to have F and F prime, G and G prime, and then you work with them methodically like that. It also goes back to what we spoke about the other day when I said, when you do your work, remember to take your time and apply your arithmetic logically. Don't look for ways to do it quickly. Don't look for shortcuts. Learn the rule, apply it, and stick with it.
So
yes.
You keep on saying in entity or what? That word.
Arithmetic.
Okay, and entities are arithmetic.
No. Oh, Lebo. Anyway, yes, I hope what I'm saying makes sense. And I mean, again, everybody's solutions are similar, but if you keep looking at mine, which I hope looks like everybody else's, you will see that then our f prime as a whole. I even put it in square brackets to show that this part is f prime, and f prime is the derivative of the numerator. And I did it all together, then kept it there because it's f prime g minus g prime f. And just so to make sure that it was going to be easily legible and I could follow it later on, I kept f prime, g prime, and f all separate in square brackets so that I could still, so that should I make a mistake, I can remember, oh, this is that part, that is that part. I hope what I'm saying makes sense.
So what they're telling me is this, ne? In
Yes.
this question, we
Yes.
have f. Our f
Yes, is whatever's on top.
f of prime is those 4 brackets using the product rule.
Yes, because f of prime is our derivative of the top. And the top happens to be a situation where we need to use a product rule to get the derivative of. And then g prime as an entity is the whole thing at the bottom, which is 3x plus 2. I mean, g is 3x plus 2, and then g prime is the derivative of that. And as we know, to get the derivative of that, we use the basic derivative rule, which is what we all know. So first, know the rule for the thing, for the main thing, and then you can use rules to, and then if you have different things, top and bottom, you can use other rules to get the derivative of those. But at the end, you must still put your sandwich back together based on the format of what you're working with as a whole picture. And in this case, our format is quotient rule.
Okay.
Yes.
Yeah.
Can you give Theo a job, please? Can someone give Theo a job, a lecturing or a tutoring job? I said, please.
Yeah.
I hope we are all on the same page now, Lerato.
Yeah, if your answer can somehow turn into my answer, we'll be on the same page. Don't worry.
Your answer can turn into my answer any day. Just do all your steps and follow arithmetic very carefully and then triple check it. And we're going to have the same answer.
Okay. May I please just come in?
Yes, sir.
From what Theo has, this is our question, eh? What I've highlighted.
Yes, sir.
And now, this is, in order to find the derivative, this is what we said. What I've highlighted. You just have to do this. Didn't we talk about this? You are just applying this to what is given to h of x. To what Theo wrote here is what I said to you. This is what we need to do in order to find the derivative of a given function, of which in this case, the derivative, a function in the numerator is 2x cubed k of x. So we find the derivative of the numerator, which is 2x cubed times k of x. First, find that derivative. And then we multiply by what? By g, which in this case is our denominator. Then minus the derivative of g, then times f, all over g squared. Abdul.
Yes, sir.
Did you send your work to us? I didn't see it.
Yesterday, sir, I was supposed to be giving an answer, Kashapaki load shedding, and I was gone like that. And I'm also going to have one now, also, 6 o'clock.
And Abdul, do you trust these people that we are with in this session now?
With Theo, sir, with Theo as part of the family, I know we'll never go wrong. Because, even if he can make a mistake elsewhere, but in terms of procedure and how he's tackling it based on his example, I totally agree with him.
Yeah, that one I agree. It is flowing from this, what I've highlighted, which I've already, is just a tool, as Lerato indicated. Yes, but somehow Lerato seems to be applying the tools
I think then it's a matter of understanding for Lerato. He must be able to separate, because I like what Theo has done. Like he said, maybe he treated the top half, the numerator, as f of x. And if you derive that on its own, you're obviously going to use the product rule. So as he wrote, so the way Theo listed it, say, I feel like it is as simple as possible. So maybe there's something that Lerato might not be applying properly, but if he's to follow, especially this logic here, Theo, I feel like he will understand what's going on if he's not fully aware of what's going on.
Abdul, can you believe that I asked everybody who's here to make sure that you get the exercise, so that today, okay, I requested them to share it with you so that you can also send your work to us, so that we can also be able to compare your answer. Did anyone share it with you?
I wouldn't say I received anything based on the mere fact that I suffered load shedding. But as soon as today, I saw pictures also in the chat and all that. So that's when I connected. I would say people who sent their work, I did see those, but I'm not sure if it was everyone's work or.
Yeah, the whole idea was that you also receive the exercise so that you can share your work with us. That was the whole idea.
So can I send my working out now to the group?
Have you got it?
Yes, sir.
Oh, beautiful. Grace us, please.
You must email me.
Okay.
No, you can post it on the chat.
Okay.
It's going to be quicker.
Say.
Okay, post it on the chat so that everybody can be able to see it. Yes.
All right, sir.
Who is Abdul's answer similar to?
I didn't hear anything so far, sir. So I think now might be the one with my own working out. But if there's anyone who might feel like my answer is similar to theirs, please feel free to share or speak up.
Okay. Now, each and every one, please look at what you sent through. Is what you sent through similar to this? Makwena?
Not really.
Okay.
Yes,
Hang on. On this one, I'm having your scripts here with me. Now,
yes.
Individually, if your answer is similar to this one, please raise, you can say yes, it does, so that we can step off this one. And if it doesn't, then also indicate so.
The screen is still blank on my side.
Hey, but there's no mistake there. That
Hang on, Ndomiso, I didn't hear you. Okay, one at a time. Ndomiso?
I'm saying the screen is still blank. Oh, there it is. Okay. No, it's fine. Thank you, sir.
Linda, are you sure there's no mistake there?
Wow. Wow.
No, because I'm trying to figure out where negative 6 comes from.
I agree with Lena to a certain extent.
No, there's a mistake there. So bad.
Hello, sir, it's very correct.
It's very
correct.
correct.
I redeemed it. It's correct. Like I agree now with what they're saying.
Okay, hang on.
You agree
Let's
with
start
what?
Level.
Yes,
Level.
sir.
Hang on, my sister. Let's first start with those who are agreeing with this answer. Who is the first to agree?
Lerato.
Lerato.
Makwena.
Makwena.
Tando.
Tando.
Tabo also agrees.
Lerato, Makwena, Tando. And then the rest of you, Abdul and Dumiso and Theo. Okay, I'm listening.
Tabo also agrees with the answer.
Who'll go first? Oh, Abdul
Well,
first. Okay, Abdul.
In terms of Abdul said, now what I'll ask is, I'm not going to be quick and jump and say I agree with it. However, if I could humbly make a request, Kuri, we go step by step, assessing each and every step to make sure everything checks out. And as soon as it does, then only then can I now commit myself to saying I agree with the answer. I'm not saying it's wrong. However, I would say, can we check it if there is a way of doing that, as in step by step
Check it,
from
you
the
have
top.
to check it so that you can
Can you, sorry,
agree or disagree.
Whoa.
You have to
Abdul,
check it before.
Level Abdul. Okay. One at a time. Abdul, let me rephrase my question.
Yes.
I'll come to what you asked me to do, to go step by step, to go with you step by step for this exercise. Okay, that one I will do. My question is your answer similar to this?
It's similar, even though somewhere the signs are not the same, but it is similar.
No. If the signs are not similar, then it means it's not similar to this.
Almost everyone say got it.
So, sorry?
Except 2 people.
Tando, what are you saying?
I'm saying almost everyone got it, even though negative 6x cubed, like by, and it's at the end there, so it doesn't matter the order.
Oh yeah.
So long.
Yeah, the order doesn't matter.
Yeah. So
the order doesn't matter.
Check mine, but me, that's one at the end. I said collecting like terms. I wanted to ask because I saw that there is negative 6x cubed and 18x cubed k of x. So I wanted to ask them, do I collect like terms? Like I added there, I said 18x cubed minus 6x cubed.
The order doesn't matter.
Yeah.
I agree with you.
But everyone got it. If you check, except maybe 2 people, Abdul and Lerad, but everyone got it. Though maybe someone started with 12x squared or 18x cubed or 6x to the power 4 there, but it's the same.
You were talking, my sister?
Yeah, it's correct, sir. Yeah, it's correct. Now,
okay, now let me go back to what you said. Let's go back. Right, this is what we are given. 2x cubed kx all over 3x plus 2. We do, remember, the quotient rule and the product rule. We first find the derivative of what? Of 2x cubed k of x. Then we multiply it by 3x plus 2. Are we clear on that one?
Yes, sir.
Yeah.
Minus the derivative of 3x plus 2 times 2x cubed kx all over 3x plus 2 all squared. Which rule is this, level?
Which one, sir?
The one that, this step.
The first step.
It's
a product rule.
It's the product as well as the quotient rule. Do we agree?
Yes, sir.
Are you sure?
Yes, sir.
Okay. Now, let's move from this step to this step. Now, Lerado? Lerado?
Yes, sir.
Is Lerado still here?
Yes, I'm still here.
Thank you, brother. Now we are going to take the derivative of 2x cubed kx first, né? What is the derivative of 2x cubed kx?
It's 6x squared kx plus 2x cubed k prime
times
of x.
The derivative of k of x.
Yes.
It is, first of all, the derivative of this. Hey, this part
It's there.
is 6x squared times k of x plus the next thing is to take the derivative of k multiplied by 2x cubed, then multiply by 3x plus 2. Are we together?
Yes, what you get.
Minus. Now we come here. What is the derivative of 3x plus 2, Lerato?
It's 3.
3. Multiply by 2x cubed k of x. Close bracket. Everything over 3x plus 2, everything to the power 2. Are we still together?
Yes, we are.
Now, the next thing that we just have to do is to what? Is to multiply out. Now, when we multiply, let's see. Let's start from, yeah. This is very interesting. But let's start with this one that I've highlighted. From this part, we will have minus 6x cubed kx, which is this first term. Do we agree? Hello?
Yes. Yes, sir.
Level, you agree now? I think it is you who tended to disagree with this term. This term, this first term, is coming from here. Do we agree?
I agree, sir.
Thank you. Now, the next thing that we need to do is to come to, okay, hang on. Now we will come to this. Let's 6. Okay, level quickly, ne? My sister.
Yes, sir.
You and I. Have you got a pen and paper in front of you?
Yes, sir.
Okay, please do this for me. Multiply k prime of x times, okay, this is 2k prime of x, ne? This
2K.
2k prime of, this is 2x cubed k prime of x. Do we agree? This?
Yes.
2x cubed k prime of x. Do we agree, ne?
Yes, sir.
Multiply it by 3x. What do we get? I did the whole thing level. Not only 6.
It's 6x to the power of 4 multiplied by k prime x.
6x to the power 4 multiplied by
k prime x.
Now it is this term. Do we agree?
Yes, sir.
Then, now you take 2x cubed k prime x, you multiply it by 2. What do we get?
Is 4x cubed multiplied by k prime of x.
Now it is this term. Do we agree?
Yes, sir.
Now we have got this term, and the first term. Now we are going to confirm where these two terms are coming from. So we are done with this part. We agree, eh?
Yes,
This middle
sir.
part. This middle part we are done. Now we are coming to this part. Is it this part?
Yes.
This will just be?
It's gonna be 18 because you're gonna say 6x squared multiplied by kx.
Oh, the derivative.
Yes.
We take the derivative of this, 6x squared kx, eh?
Yes.
This is
We
going to
mul-
be
We multiply it by 3x.
where is the 3x?
And just say
Oh, sorry. Oh, so we multiply this whole
thing
hang on,
with
hang on. We multiplied this with this whole thing. Ne?
yes.
Now where is this one going? Level?
Now that one we have to multiply it again with 3x plus 2. But we will start with 3x. It's gonna be 6x squared kx multiplied by 3x. And then it's gonna be 18x cubed kx.
So
And then in 6x squared.
hang on, level. Something is there is a big bracket that I don't see here. There should be a big bracket here.
Big bracket.
Big bracket, yes.
Yes, sir.
Do we agree? Level, you are saying now we are multiplying 6x squared kx by 3x, eh?
Yes.
In order to get 18x cubed kx, this term, eh?
Yes.
Then finally, it is 6x squared kx times 2, which is giving us this term. But what I'm saying is that there is a big bracket that is missing.
No, sir.
There's no big bracket. Which one, sir? No,
Yes,
I
Tando,
don't.
I heard you saying no. Oh, no. This is what I meant. This is what I meant. You see from this bracket, you see this bracket, this first bracket, to this bracket. Do you see that? What is inside this bracket is all these terms are inside this big bracket. This is the big bracket that I've been referring to.
Yes.
Yes. Now multiplied by 3x plus 2. Level, did you get this?
I got that, sir. Exactly, exactly that one. But this guy here started
Which
with
guy?
negatives. The one who wrote this book.
Yes.
Okay. I will assume it's you, sir, who wrote this book. So now you started with negative 6x cubed kx, and then mine. It was my last term, that one. Negative 6x cubed comes from that 3 in bracket 2x cubed kx, close bracket, comes there. I can see.
Okay. Tando, did you need to say something?
Yes, sir. I just wanted to agree with this answer. Though, if you check there, k prime of x dot 2x cubed. Do you see the second and third one? So they treated that thing as one. Like, so we are expanding now 6x squared kx plus 2x cubed k prime of x in the first bracket.
Yes.
Then we are multiplying it by 3x plus 2.
Yes.
So that dot, it mustn't confuse us. We must treat k prime x as you started times 2x cubed. Treat it as one term.
Yes.
So that when we expand there, we are having 4 terms, like Lebo was explaining. So I understand why they started with -3 in order not to confuse us. Because some other students, we can multiply, maybe try to multiply 3x plus 2 with that other bracket, which is not correct. So I understand why they started with taking out that -3 times 2x cubed, because it's simple. Then now we are dealing with what? With that expansion. We have to expand 6x
with a big bracket and a small.
Yeah, something like
Small
that. So
bracket.
that's why when they started with negative, they were done. Now we are expanding the first bracket with the second one. So they said 6x cubed, 6x squared kx times 3x. Then they got 18x cubed kx. Then they multiplied again with the same 6x cubed. Now we are multiplying it by 2. That's when they got 12x squared kx. We are done with first and with the first term and the second in the bracketed there. Then we are dealing now with 2x cubed k prime of x, multiplying it now both terms in 3x plus 2 there. That's when they got 2x cubed k prime of x multiplied by 3x. Then we get 6x to the power 4 k prime of x. Then again 2x cubed k prime of x times 2. They got 4x cubed k prime of x.
Thank you, Tando. Can we, okay, before I step this F off this one, is everybody happy?
Yes, sir.
Yes, you.
I'm happy.
So
Sorry?
I have a question.
Two people are talking. Theo spoke, Lebo is speaking. Okay, Theo, then Lebo.
No, I said I'm okay, sir. I'm okay.
Oh, okay. Lebo?
Yes.
Yes, sir. Is it necessary for us to simplify?
To simplify, meaning when you are saying simplifying, are you referring to this step?
Yes.
Yes.
And other people got another step because they said -6x square s cubed kx plus 18x cubed kx, and they got 12x cubed. So that's why I'm asking, is it necessary? Because I don't know, sir.
Is necessary where they are like terms. Okay, now let's look at this last step of us. Are there, in this step, are there terms that can be added or
Yes.
subtracted from each other?
Yes.
Okay, which terms can be added or subtracted?
First two terms.
First two terms. Okay, you see there is something missing there. So that means we need to go a step further and add these two. Do we agree?
Yes, sir. That's why I'm asking. Because like when we go further simplifying this thing, we make mistakes and we get our answer incorrect. Am I going to be incorrect? They are going to mark me incorrect if I leave it there where I derive it.
Whoa, level.
Yes, sir.
In this step, you and I agree that these two terms, the first two terms, these two must be added together. We agree. They are like terms.
Yes.
So we should have one term here, which is 12x cubed k of x. Do we agree?
Yes, sir.
Then, is there any term that can be added to this one? Any term that can be added to this one?
No, sir.
And finally, there will also be as an answer for the last term.
Yes, sir.
Yes.
So am I going to be incorrect or am I going to miss other marks if I don't simplify?
If this was, let's say this exercise was worth 5 marks, and then if this was the fourth step, then that means you'll only get 4 marks.
Oh, okay.
because it is only one step to the final step from here.
Okay, sir.
Okay. Are we all happy? If we are all happy, including Lerato,
I'm happy, but not happy at the same time because I could be load shared at any time. So anytime I could be out.
Can I just make a comment? I wanted to add on to I think it's Lebu's question. If you look at that step where you have negative 6x cubed kx plus 18x cubed kx plus 12x squared kx plus 6x to the power of 4 k prime of x plus 4x cubed k prime of x, right? You're going to add the first two terms. And if you look at that, you can still take out a common factor of 2x squared. So I just wanted to add on to Level's question that simplifying further, if you did not simplify, well, they penalize you for that because you can still go further and take out the common factor. Which one affects the last your answer, because it doesn't do anything with the denominator if you expand the denominator. So I just wanted to add on Level's question. Thank you.
okay. I'm still sticking to my gun here to say these two, there is one last step that is missing. These two should be added, whether at the end, because you'll be having 12x cubed kx, whether you will need to take out the common factor or what, that is another thing. But these are like terms. They should be added together. May we please,
Noted.
thank you. May we please step off this if everybody is happy.
Yes, sir.
Any question?
No.
Erica?
I have a question, but I can't see what you said in there.
Sorry?
I can't see the page that you said. I
You can't
don't have
see?
a question, but I can't see what you said in there.
I can hear you from very far. Anyone who's audible, can you please share with me what Erica is saying? Erica, you are speaking from very, very far.
Is this better?
Yeah, it's better. It looks like you were in a mine.
Okay.
Yeah,
We
now it's
did
much
switch
better.
from load shedding now, so maybe that's the thing. But I can't see what you shared. I can't
You can see.
Yes.
Please ask everybody whether they can see my screen or not.
Can you guys see, or is it my problem? Is it a problem on my side?
This side is clear.
I can see.
I think it might be a problem on Erica's side because I also had the same problem. I couldn't see for a little bit, for about a few minutes, and then it came back.
Okay, thank you. I'll see what I can do.
Okay.
Try leaving and coming back.
Okay. Erica, please do so. Leave and then rejoin.
I will do so. Thank you.
Thanks. Can we now go into the future?
Yes, sir.
Can we comfortably walk into the future?
Yes, sir.
Proudly and comfortably. Okay. Now, let's go. Now, here is my request. In this exercise, they are saying, find the derivative of the following functions and simplify your answer. Okay, let's say up to number 9. Can I request that you do 1, 2, and 3 at the same time? Then we'll group ourselves in terms of allocation allocation to the responsibilities for sharing the answers for each question. Now, let me request you in this way. Please work out number 1, 2, and 3 at the same time. When you say you are finished, that means you will be finished with 1, 2, and 3. Okay, Tabo, number 1 will be yours. Theo, number 2 will be yours. Erica, 3 will be yours. Tabo, what did you get?
I got 7x to the power 6.
For number 1. Please ask them whether they agree with you or not.
I agree.
Do the comrades agree?
I agree.
Agreed. Any disagreement? Okay, there seems to be no disagreement. Thank you, Tabo. Theo, number 2.
The answer is 15x squared minus 1.
Please talk to them.
Ladies and gentlemen.
I agree.
Thank you.
I agree also.
I agree.
Thank you. Erica, number 3.
I've got 8x minus 7.
Please talk to them.
Do you guys agree?
It's perfect. Thank you, ma'am.
I agree.
agrees.
Thank you, everybody. Now, let's work out 4, 5. Let's wait. Okay, let's say 4 and 5 at once.
Lerato is done.
Are you sure, Lerato? Okay, Lerato.
Yes, sir.
Yes, my brother.
Will you skip 6 or will you do it also?
We are going to do it.
Okay.
Makwena is done, sir.
Makwena, where have you been?
I've been here.
Huh?
I've been here, sir.
Oh.
Yes.
You must just interrupt us. You must just interrupt us. We'll like to hear your voice, man. People like you and Tando. Eh?
Today I don't have a voice.
What happened to the voice now?
I have a flu.
Oh, I thought you sold your flu. I thought you sold your voice. Sorry. Please. I wish you a speedy recovery. Eh?
Thank you, sir.
Okay.
Who
else is finished? 4 and 5.
Erica is done.
Theo's done.
Elvin's done.
I'm done.
Erica. I captured Lerato, Makwena, Ndumeso, Theo, Erica. Who else?
Tando.
Elvin's also done.
Tando. Who else?
Elvin.
Elvin. Yeah, Elvin. Thank you, my brother. Elvin. Now let me come here. Elvin, what did you get for number 4?
For number 4, I got 32x cubed plus 18x.
Please talk to them.
Hello, everyone. Did you get the answer?
I agree.
Sister agrees.
I agree.
Please repeat your answer.
32x cubed plus 18x.
Ndumeso agrees.
I agree.
Thank you, Alvin. Welcome, Specific.
Yeah, to be back, sir.
Okay, thank you. Now, who should I? Makwena, please.
Yes, sir.
Yeah, please exercise that voice of yours by giving us an answer to number 5.
That's 4x cubed plus 2.
Louder. I didn't hear that.
Okay, 4x cubed plus 2.
Thank you, my sister.
Oh.
Please talk to them in Magwena.
Do you guys agree with me?
Yes, we
Agree.
do.
Thank
I
you, Magwena.
agree.
Please repeat your answer.
It's 4x cubed plus 2.
Ndumiso agrees.
Thank you.
I agree.
Thank you. Now, Lerato.
Yes, sir.
You are going to lead us in giving
No.
us an answer to number 6. I'm giving you 2 minutes to do number 6, but Lerato will lead us.
I'm done, sir.
Did you double check your answer?
Yes, sir. If it's wrong, the first time it's wrong every time.
No. Lerato, man. No. Please double check your answer. I'm giving you 2 minutes to double check your answer.
Sir,
Yes.
when you multiply exponents of the same base, you add the exponents.
Same basis add exponents.
Okay, then it's fine. I'm done. I will check in.
Okay. Let's wait for 2 more people.
Lebu is done. You can see she's laughing.
No, it's a big number, so I have to take my fingers from my leg fingers, my foot fingers, and my hands fingers. So
Yeah, you can even ask for fingers from everybody in the house.
yeah. Yeah, but I'm done. No, I'm done.
Are you okay? Then Lebo.
Followed by Makwena.
Sibusiso.
Makwena, Sibusiso. Okay. Now, Makwena.
Ndumiso's the answer.
Thank you, Ndumiso. Makwena.
Oh.
Yes, sir.
I would like to, remember I said we are exercising that voice of yours to come back to normal, eh?
Yes.
Yes. What did you get as an answer?
Sir, I got open bracket 18x cubed. Now what am I saying? Yeah, it's 3 into 18x cubed plus 18 over x plus 1. I didn't expand, plus 3x open bracket 72x cubed minus 13 over open bracket x plus 1 squared, and then I close the bracket. I didn't expand it.
Please slowly this time.
Okay. It's 3 open bracket 18x to the power 4 plus 13 over x plus 1 close bracket plus 3x open bracket 72x minus 13 over x plus 1 squared. And then I close the bracket. That's where I ended.
Interesting, man. Yeah, very. I like it. Please talk to them, Makwena.
Do you guys agree?
I agree.
Is that what you got? Okay.
I disagree.
Okay.
Can you repeat again, please, Makwen?
Okay. Oh, Makwena, can you simplify it further? Like finish it.
Okay, let me simplify further.
Okay.
a minute.
Okay.
Sorry, can I ask Makwena, before you continue, you said it's minus 13 over x plus 1 all squared. You said minus, right?
Yeah, I
Please
said
give
minus.
Please give her a minute to finish, then we will talk to her.
Okay, thank you.
Oh, thanks, bro.
What is 72 multiplied by 3?
216.
Thank you.
Oh, now are we allowed to ask you, like, say, if you need a answer for multiplying a bigger number?
Sorry, Lebo?
If we are allowed to ask you when we want answer if you multiplying a bigger numbers.
you can ask us. We can help if we can.
Okay.
Hmm.
Okay. So
Magwen, are you finished?
Almost done, sir. Almost done. Almost done. You said it's 250?
216.
216.
Yes, ma'am.
216.
Yes, 216.
Thank you so much. I think I'm done.
Are you sure?
Yes. Yes.
Okay.
100.
Oh, okay. May we all listen to Magwena's answer? Please say it again and again, Magwena.
Okay. I have 54x to the power of 4 plus 39 over x plus 1 plus 216x to the power of 4. I should have just added 15 with 216. Okay. Yeah. Yo, this is a lot of work. Okay, I have 270x to the power of 4 plus 39 over x plus 1 minus 39x over x plus 1 all squared. That's my answer. That's my final answer, sir.
Sounds good. Thank you.
Anyone who has got a comment for Magwena in terms of whether Magwena
I
got what
disagree.
we were supposed to get or not?
I disagree.
Disagree.
Ndovisa,
Where
got your
is
different answer.
Makwena? Makwena?
Yes.
Where is 39x? I don't know, to the power something comes from.
Mina, I would say, okay, now
After 270. Okay, after 270x to the power 4, you said is 39x to the power what?
It's plus 39 over x plus 2 minus 39x over x plus 1 all squared.
Okay. Question: why is it 39 over x plus 2? Yes, isn't it 39 over x plus 1? Please recheck.
Okay, I took 13x
Yes.
over
X
x plus 1.
Yes.
That's what I made it. I wrote it this way. I said it's 13 open brackets x plus 1 to the power of -1, and then I used a power rule to derive that.
Okay.
No, I'm not sure about that part.
Sir,
everything else seems fine though.
Like everyone will agree that it's 270 x to the power 4, like the first term. The other side, me, I got plus 39 over x squared. That's what I got.
9 over x squared. Like you got 2 times.
No, like 270x to the power 4 plus 39 over x squared. That's it. That's the answer. Because the 13x to the power negative 1, when you multiply it by 3x, it becomes 3. 13 is 39. 1 minus 1 is 0. X to the power 0 is 1, which is 39. 39 is a constant. Therefore, when you derive, it disappears.
Yeah, when you are missing one thing, you missed one thing there.
What? No, what?
What? Like you missing one thing every time.
No, what am I missing?
Lerato.
You said your answer is 270x to the power 4.
Plus 39 x squared. That's it. It's there.
X squared.
Yeah, you're missing something there, Lorato.
Yeah.
Because you have a product rule there. Product rule. You are running away from product rule every time.
They didn't say we should use product rule.
So, yeah, okay, it's a combination there. If you can analyze this number 6.
No, Lebu, you're right. Lerato.
It's a combination of 3. It's a combination of 3 rules there.
Which rules now?
Because first thing first, you have to break the bigger bracket. First thing first. Also, you have to multiply 3x with 18 to the power 4. So you'll get 54x to the power 5.
Lebu.
And then, yeah?
My answer is halfway there. That means it's fine because I'm halfway there. You said I'm missing something. What am I missing?
You are missing best product rule. Another thing you are missing, it's a power rule. Yeah.
Where is the power rule? I can't see it.
You can't see it.
Even the product rule, I can't see there.
Lorato.
You have x plus 1 in bracket to the power negative 1. And just
yes.
Hey.
Stage.
After that thing, yeah, 39x in bracket x plus 1 to the power negative 1. It's a combination of 3 rules here. Because
I removed that bracket that you are speaking about.
You remove it?
Yeah, 13 times x to the power negative 1 is 13x to the power negative 1.
Lorato.
Repeat again.
Can I ask a question?
Yes, you can ask the question.
The 3x at the beginning, did you distribute it?
At the end, far end, when I'm done with the bracket.
Okay. I'm saying, so you didn't distribute it at the beginning?
No, I didn't do it at the beginning. I did it at the end. Because I thought it was power rule only. I don't see the other rules here. I see no power rule.
Oh, okay. Lerato, may I please comment?
You can comment.
Okay, thank you. So it's got to do with what Ndumisa just said. So the way I see this, you can do it in 2 different ways that are very different but very similar. Hear me out. So you could initially distribute the 3x into the bracket, and then by doing so, you were gonna have the normal power rule. I mean, you're gonna have the normal power rule. Then you're gonna deal with power rule and quotient rule. You could do that, or you could you could solve this via the product rule, because then 3x is one term, then what's in the bracket is another term. But either way, you'll get to the same answer. But then the thing now is, if you decide to treat it as product rule, you're going to have product rule, power rule, and quotient rule in one. If you don't distribute. And if you distribute, you'll just have power rule and quotient rule. Either way, you will get the same answer.
What I'm trying to say is this. You are telling me that 13 is a function.
Well, look, well, I mean, if you're gonna 13 over x plus 1 is, you would have to derive that and you treat that as product as quotient rule.
But like 13 is not a function.
Yeah, you are telling the truth, Wananto.
Yeah.
13 is not a function.
Yes, but it's
And
fine
then
because look at it. Okay.
You can't derive something that is that you can't derive if a function is in denominator. You have a number in numerator and then
Yeah.
function.
Okay, listen, Aneli. This is how I did it. The 13 there, I made it 13 times x plus 1 to the power negative 1. And then I distributed negative 1 to x and also to 1. So that I can remove that bracket. And then I got 13x to the power negative 1 plus 13 to the power negative 1, which is 1 over 13, which is still fine. But if you are saying 13 is a function, then I'm wrong.
13 is not a function.
So why do you then rule on 13 if it's not a function?
Kupa, check the chat. Can you please check my chat? Your chat. See what I'm talking about. Can everyone see?
I can see what you're talking about, Lee. Yeah, I can see. Okay. Oh, yeah.
You see now, 13 is not it is not a function, and then under 13 is x plus 1. It's a function. You can't treat x divided by x 13 divided by x plus 1 as a quotient rule. Theo.
Lebu, please give me 2 minutes. Please. I'll get back to you.
Lebu. Like you do everything the same until the second last step where you introduce 2 brackets, but there was 1 at the beginning. Why, like, oh, you use the product rule there.
Yes.
Okay, now I can see what I'm missing. It's fine then. Yeah, it's fine.
Are you sure?
Also, I was supposed to get 270x to the power 4 plus 39 over plus 39 over x squared. That's the answer.
Please repeat it, Rato.
270x to the power 4 plus 39 over x plus 39 over x squared.
Do you mean 39x over open bracket x plus 1 close bracket raised to the power 2?
Yes, that's okay. Yeah, it makes sense now. Or the minus 1 does not go anywhere. I bring it to the denominator also. I don't derive it, the minus 1, because I derive my case.
I think it depends on how you tackle the question. So that's why initially I asked if you distributed, because from my perspective, distributing first would have been easier than
doing it half. Yeah, I understand now.
But then, as Theo said, there are many ways to skin a cat. So
yeah, either way, you still get the same answer.
Yeah. So I'm sure the way you.
It's fine. What Makuna got on the
yes.
Yeah, that's what.
But
yeah.
Can I ask Lebu? Is it Lebu who puts it in the chat?
Okay. Yes. It's
what you did there with your x plus 1, right? So it's x plus 1 all to the power of negative 1, isn't it?
Yeah.
Yeah. I just want to know, wouldn't you have to use a chain rule there because you have a function inside a function?
No. That's my point. You can use is it a quotient rule? You said a quotient rule or chain rule?
No, I'm saying on what you did. You have 39 into x plus 1 all to the power of negative 1, right? Yes, that's what I'm talking about. So you have x plus 1 all to the power of -1. You have a function inside a function there. Wouldn't you have to use a chain rule?
Whoa, a chain rule, you know, I can see something and then I know how to do it. I don't know if it's a chain rule or quotient rule. Which one is a chain rule?
Well, you have a function inside a function.
A function inside a function.
Yes, you'll have to first derive the outside function and then keep the inside function and then derive the inside function.
Oh, yeah. X bracket in bracket is x plus 1 to the power -1. It's a chain rule, right? That one, yes. And then in 39, still 39x is a function, and then x plus 1 in bracket to the power -1. It's a function, so we have two functions there. So it's a product rule for me there again.
And the chain rule.
Huh?
And the chain rule.
It's a combination. It's a chain rule and product rule there. That's why you see that in a big bracket. I say it's a 39. I started deriving 39x first.
Yes.
So I got 39. And then multiply by x plus 1 to the power -1. And then the whole thing is a product rule minus. And then it's 39x. And then I'm deriving now x plus 1 in bracket to the power -1, which is that one is a chain rule. Anja? Yes. So that's why I got negative there and to the power -2 multiplied by 1. That one comes from x. When you derive x plus 1, you got a 1. Anja?
I hear you.
I don't know who I'm talking to. I'm talking to
You're talking to Tabo.
Tabo. Oh, Tabo. Oh, it's the first time hearing you, Tabo.
It's the second time actually, but it's fine.
Yes. No, like Tabo. Kamo katlasing. It's my first time.
No, it's okay, Lou. It's okay. No, I just wanted clarity there. Thank you very much.
So, I want to emphasize this one, guys. Tuthiyo.
Yes.
I want to emphasize this one. 13 divided by x plus 1 is not a quotient rule, that one.
Okay.
Yes. It's 13 is not a function, it's a number. So you can't treat that one as a quotient rule.
Noted. Thank you.
Yes.
Level.
Theo, are you agreeing with what Level is saying?
Yeah. I mean, because what she's basically saying is for what's this? For 13 over x plus 1, what Level's saying is that we could pull the 13 out as a constant. And then we'd be left with 1 over x plus 1. Yeah, look at it that way. So we'd pull the 13 out as a constant, and then it would be 13 multiplied by 1 over x plus 1. Then we derive that.
I see.
The 13 is going to stay, and it's going to get multiplied by whatever the derivative is of 1 over x plus 1. Yes, ma'am.
Okay.
Thank you.
No. If no, it's okay.
Level.
Yes, sir.
Okay. How do we sum it up? Magwena has given us an answer, and then what are we saying? Okay, what is the final answer?
Magwena agrees with Lebu, say.
Yes.
The same answer.
Magwena agrees with Lebu.
Yes.
And then what is the final answer?
What is the final answer, sir? You have to confirm to us.
Okay.
Can I take a stab?
200. Oh, you can. Yeah, you can.
I'm not confirming. Lebu, I told you that I don't know these things that you are doing. I'm learning from you.
Okay. I mean, I'll take a stab at it, but before I say what the final answer is going to just take like 30 seconds to just run over my methodology.
Okay.
Yeah, so what I did is I distributed the 3x into the bracket. And then by
Then
doing
you
so,
had,
yes, so I distributed the... Sorry, sir?
You?
Yes, sir.
Yes, brother, let's distribute together.
Yes. So I distribute the 3x into the bracket, and then by doing so, I end up with 54x to the 5 plus 39. Yes, sir.
54x to the power 5 plus 39.
39x over x plus 1.
Over x plus 1.
Yes, sir.
Yes.
And then next step, I derive 54x to the 5, and I get 270x to the 4.
Hang on. Meaning you found the derivative of 54x to the power 5.
Yes, sir. And that gave me 270x to the 4.
270x to the power 4.
4. Yes, sir.
Thank you. Now we are going to the next term.
Now the next term is, Level laugh at me. We now actually do have a function, so we can use quotient rule on it because now it's 39x over x plus 1, correct?
Now we have?
I'm saying for the next step, you know how initially we had 13 over x plus 1, and that wasn't a function we could use quotient rule for. But upon multiplying that with 3x, we now have 39x over x plus 1, right? And that's a function that we can use a quotient rule for. And therefore, using the quotient rule for that function, we end up with 39 multiplied by x plus 1 minus 1 multiplied by 39x over x plus 1 squared. And then simplifying that, yes, sir.
Using the quotient rule.
Yes, so we get f prime.
Find the derivative of 39x, ne?
39x over x plus 1, yes. And so f prime is 39. So it's f
multiplied by x plus 1.
Multiplied by x plus 1, which is our g.
Yes.
And then it's minus g prime, which is 1, multiplied by f, which is 39x.
Yes.
And all of this is divided by x plus 1 squared. Yes, over x plus 1 squared.
Then from there,
next step, we rewrite the 270x to the 4 again because we're not touching it for now.
Yes.
And then simplifying what we had with our derivative for the quotient, we then have 39x plus 39 for the first two brackets. Minus
39x.
Minus 39x. And then we do a bit of arithmetic all over x plus 1 squared.
Plus 1 squared.
Yes, sir. And the next step, we still have our 270x to the 4. We're not touching that. And then we're simplifying the next bracket. We're simplifying the next bit of the equation. So 39x minus 39x is going to cancel out. And then we are literally left with 39 over x plus 1 squared.
We agree.
And then our final answer is 270x to the 4 plus 39 over x plus 1 squared.
That's how we conclude.
Yes, I agree with you.
Thank you, ma'am.
Please repeat your final answer, Theo.
Yeah, final answer is 270 x to the 4.
Yes.
Plus 39 over x plus 1 squared.
I got 39x over x plus 1 squared.
So, okay, it's fine. Let's backtrack a few steps. Are you ready? Remember the part where I said when we started distributing for the quotient function after we derived it? I said we had 39 multiplied by x plus 1 minus 1 multiplied by 39x. And so minus when you minus 1 multiplied by 39x. This is all the numerator. Yeah, in fact, guys, let's not make this complicated. Give me 2 seconds and I'll just send the picture. How's that? I'll just send the picture. Give me 2 minutes and then I'll send the picture. Should make it easier for all of us.
Yes, please.
So is it possible that we get the answer and while Theo is sending the...
Sorry?
Is it possible that we get the answer while Theo is sending his workings?
The final answer.
Yes.
The The final answer is 270x to the power 4 plus 39 all over x plus 1 squared.
Yes.
Okay.
Thank you.
Only.
Is it not 39x, sir?
No.
Hello, sir.
Hello. Yes, Tando.
Okay.
Hang on, Tando. Ndumiso, the 39x cancelled in the previous step. Positive 39x and negative 39x cancelled out.
Oh yes, I see, sir. I see. Yes.
Okay, thank you.
Yeah.
Tando?
No, I don't see anything, Sean.
Okay,
No,
hang
sir.
on. Tando?
Yes. Yeah, I just wanted to say Makwena's answer is correct if he leaves, if it's like that, ne? But just to expand the 39 open bracket x plus 1, ne? Like what Theo was saying, then minus 39x. If we expand that bracket, that's when now we are going to get 39 over x plus 1 bracketed squared.
Okay.
So it was correct, but she was supposed to simplify further.
Oh, ladies and gents, I
Is
posted
he
it
here?
for anybody who wants to see it.
Tando, please tell Makwena.
It seems she agreed. Said she's talking behind us. She's saying she didn't simplify further.
I'm simplifying it further. I will send it back on the chat.
Thank you, Makwena.
Yes, sir.
Hey, this flu.
She must get better. Eh? We wish her speedy recovery.
Yeah, she'll be okay.
Sir,
Yes, Lerado.
when I spoke my answer, they said it's missing one term. I was crucified. And my answer is the one that Theo has posted of 270 x to the power 4 plus 39 all over x plus 1 squared. But I was crucified when I said so.
In that case, Lerato, we owe you an apology. We apologize on behalf of everyone.
Yeah, there we apologize.
So we
Sorry,
are
Lord.
sincerely sorry.
It's fine.
Yeah,
It's fine.
we apologize.
We apologize. We'll do better next time.
Lerado, we apologize. Level?
Yes, sir.
Come on, your class. Please apologize to Lerado.
I'm apologizing, Lerato, but there were no crucified.
Whoa. Not bad.
Unconditionally. Honorable member, unconditionally withdraw your statement.
Please, Level.
I say it's fine, but
I'm
when it was
so.
coming,
I'm
it's
so.
fine. Sir.
I'm so.
It's fine.
Yeah. Okay. It's all in the name of learning. Yes. Sorry, Lerado, these things do happen, but at the end, we need to keep focus. We need to mainly aim at our target. What is our target again, Lerado?
Distinction.
The future of distinctions.
No,
yes.
distinction.
The future of distinctions. Thank you, everybody, for having attempted all these exercises up to so far. Now let's see. I need to step off this. Yeah. Okay, now let me look at this. Lerado. Oh,
Yes,
I've already
sir.
shown that. You see, this is what we've been looking for. Yeah.
Number 8, I'm done. Me.
No, I mean number 6. Yes,
that's what I thought.
Okay. Now, let's do 8, 12, 8, 12, 8, 8 and 12. Here is 8, okay?
Sir.
Can and one level? Can you all see number 8 level, including you level? Can you see number 8?
Yes.
We can see.
Yes.
Okay, level, you can say what you needed to say.
I can forever hold my peace or what? Because I'm
No,
not
talk.
satisfied.
Oh, you are not
Okay.
satisfied? No, talk. We are listening.
For 39 over x plus 1 to the power 2, can somebody simplify my bracket so that I can get 39 over x plus 1?
Okay. In the meantime, so please move your cursor from number 8. I can't see the power to the power of x.
Level, what are you
Oh,
saying, my sister? I need
thank
to
you.
help you.
I'm saying, sir,
Yes.
the correct answer is 270x to the power 4 plus 39 over x plus 1 in bracket to the power 2, right?
Yes.
So now my answer is not corresponding. And then I need a help, assistant. Anyone, can you please simplify the whole bracket from my answer?
Which bracket, my sister, so that I can help? Level?
Yes, the bigger bracket. See on the chat before the final answer.
I'm not on the chat, but okay, let's talk about this final step, you and I. We are saying our answer is 270x to the power 4. Do we agree?
Yes, I agree.
39 over x plus 1, everything raised to the power 2. Is x plus 1 raised to the power 2? Is it the bracket that you are referring to?
Yes, the number 6, yes.
X plus 1, open bracket, x plus 1, everything raised to the power 2. Is this the bracket that you are referring to?
X plus 1, which one? From my answer?
No, not from your answer, from our answer.
Yes, from your answer, sir, you got 270x to the power 4 plus 39 over x plus 1 in bracket to the power 2.
39 over, open bracket, x plus 1 to the power 2. Do we agree on that one?
Yes, I agree with that.
Is this the bracket that you need assistance with?
Yes.
Which one, sir? I can't see anything. I see the question on your board.
Last in our answer. Oh, level. Where is this thing? Level here. Do you need an? Do you see what I've? Do you see my screen?
Yes, sir.
Do you say you need an assistance with this bracket?
No, not that
Which
bracket.
one?
I need to get that answer from my bracket. From the chat, sir.
I'm not on the chat. Okay, can anyone who is able to see on the chat help level?
Yes, please.
Okay,
I'm on this page. That's why I don't see what you are talking about.
Lebu.
Guys, is it possible that if you're not
mute guys, mute your mics.
yes, please, if you're not speaking, please mute your mic.
Lebo,
yes,
you say what you are referring to? Lebo.
Yes, sir.
You say what you are referring to is on the chat.
Yes.
Is that what you said? Okay.
Yes.
Members, can anyone who is able to see in the chat help Level? And then Level, you'll have to be specific in terms of the bracket that you are referring to, because I don't see
Yes.
it.
Yes, sir.
Anyone, please? Anyone?
Anyone, please.
Okay,
there's
Level,
no...
then be quiet.
Okay, I should forever hold my peace, sir.
Please ask anyone. Ask anyone.
I can ask. I
Is
can
yours
help
in
her
red?
say.
Anyone, please.
Lerato,
Yeah, whatever. Okay, like what I see, Anne, you use the product rule for that bracket for 13x plus 1. Okay. 13x plus 1 to the power of negative 1. And then you got, or you multiplied by 3 and got 54x to the power 5 plus 39x all over x plus 1 to the power of negative 1. So there are two functions there. There's 39x and there's also 3x plus 1 to the power of negative 1. Okay. So first derivative of 39x is 39, and then you left with g of x. And then derivative of x plus 1 to the power of negative 1, k x plus 1 to the power of negative 2, which is correct. And then 19x plus x to the power of 1, it over 19x plus 9 plus 39, like 19x to the power of 1 plus 39 to the power of negative 1. I understand that, Mina. And then it
I don't know
over
19. So, Lerato, I don't know where you get 19.
39x to the power of negative 1 plus 39 to the power of negative 1 minus 39x ka phetape. Wa bona mo le x e le tshwanetse be x squared akere. Wa bona? So 39x times x to the power negative 2, it's 39x, because it's gonna be 1, it's gonna be like 1, x to the power of 1 minus negative 2. So it will be 39x to the power of minus 1. Okay? And then to be negative 39 x to the power of minus 2. Do I understand until? And then x to the power 39 x to the power negative 1. It will cancel at 39 x to the power negative 1. If I understand that, Mina. Or if I understand this still.
All right.
Second, I can get 39x to the power of 1 times x to the power of negative 2. Say when you multiply same base, the exponents add, it over 1 plus negative 2, then to sala ka negative 1. And then ko bracketing it up, re tshotse 39 x to the power of negative 1 minus 39 x to the power of negative 1. They cancel each other out. Re ba left kang ka 39 to the power negative 1 le 39x to the power of negative 2. Okay. Oh. Yeah, I want to expand that too. Because
I can see now. Yeah. No. I can see what I should have done to get
Anyone? Okay. Level.
Yes, sir. I got it. You can see
please
on
thank Lerato.
Lerato.
Please thank Lerato.
Yeah, that's I can see now what I have done after that step. You see on the chat.
Oh yeah, I can also see that.
Yeah, thank you.
Lerato gave an explanation to Level. And then somewhere Lerato got stuck. Then Lebo just said, no, I noticed what she said, no, she has realized her mistake. And then while Rato was explaining, you were following. And then we didn't get to the point where you needed to say in terms of helping out Ndumiso. It was not by mistake.
Yeah, I guess so, sir, but
Yes.
since she's answered, then yeah.
Please. Ndumiso, please
Yes, sir.
ask Lebo whether she's answered, whether she needs further
sorry.
explanation from you or not. Yes.
Lebo, you good?
I'm 100 Ndumiso.
Okay, no stress. Thank you.
Thank
you,
you.
Ndumiso. Lebo, please thank
Yes.
Ndumiso and Lerato.
Oh, thank you guys. I was burning. Ndumiso and Lerato, thank you so much.
Thank you, my sister. That's why we are here. We are here for each other. Okay, now let's do this. Please take a screenshot of this page. Do you see this page that I'm on? Number 8, 11, 8, 11, 12. Yes.
I had 8, 11, and 12.
8, 11, 12, and 13.
Just to clarify, sir, what must we do for homework? The numbers, please.
8.
Yes.
11.
Yes.
12 and 13.
8, 11, 12, and 13.
Yes.
Thank you, sir.
If we can do that, when we meet, then we'll quickly answers, and then from there, I think I'll check the next section that we'll need to. Oh, then there are 2 more exercises. It will be a matter of finishing this. And then I've got 3 more exercises, 3 and 3 more, 6 more. Then from there, we'll go to the next section.
All right.
Is this 3 or is this 4 plus the 6 that are remaining? Then from there, we go to the next section.
All right.
On this page, we're only looking for number 8 and 11. Is there any question from any related to what we talked about today?
No questions.
No question. Is everybody happy? I don't need anyone to leave this session being angry.
No, I'm happy. I'm happy. Oh, and from my
Ladies
side,
and
thank you to everybody for everything. And Lebo, thanks for the teaching moment again. It's going to save me a lot of trouble down the line. Thank you very much.
Thank you so much.
Thanks, ma'am.
Let me say it again to everybody. The purpose for being here is to learn from each other.
Yes,
Yeah.
sir.
Not to belittle anyone. No, that is not the reason. The reason is to learn from each other, help each other out. It is not a platform to show that, no, I'm better than you. No, no, no. That is not the reason. We are here to help out each other. Can we then say we can safely go to sleep without any nightmares?